Okay, so one more of these videos I'm going to do for you. By now, I think you figured out that the name of the game is to determine the moment of inertia of each component, and then we just put all those things together. Now, take a look at this one. Here, we've got a disk, but somebody has cut a square out of the middle of it. And so it might kind of feel like, how do we do this in parts? Okay, there's a lot of different ways you could try to think about doing this in parts. But let me tell you what the easiest way is to do this is going to be. Let's suppose that you had two objects, and you knew if you stick these two objects together, they're going to have a certain mass. Okay. Uh-oh. So M3 is M2 plus M1. It follows then algebraically that M2 has to be M3 minus M1. Okay, so what we're going to do here, like let's say we wanted the mass of this object, we'll treat it like it's two different pieces. We'll treat it like it's some outside piece here, and we'll call that M2, but M2 is equal to the big disk minus the inside portion, just like that. So the big disk is M3, and the square portion is M1. Okay, now that got messy quick. So give me just a second. I'm going to try and clean some of this up. Okay, all right. So one more time, M2 is the disk with the hole in it. M3 would be the would be the whole disk. Okay, like this. And M1 is just this rectangular portion on the inside. Okay, now that I'm sure that makes perfect sense. But we can do the same thing with moments of inertia. Okay, so that means I could come up here. I could say that my moment of inertia of the disk with the hole punched into it is equal to the moment of inertia of a plain disk minus the moment of inertia of the hole that's punched into it. So that's how we'll crack this nut, is we'll get I3 and I1, and then we'll just subtract the two, and we'll be good to go. Okay. So I3, that's for the disk. So we're going to have 1/2 M3 R3 squared, plus there's an offset, so we have M3 D3 squared. So if we put in our numbers, we don't have our numbers yet. We need our numbers. Okay, we've got to figure out the value of M3 and the value of M1. All right, so a tricky part about this one is they say, kind of like in the last one, they gave us a mass per unit length. Here they give us a mass per unit area of 20. So we need an area times this sigma value in order to get the correct answer for our mass. Okay, so if I come up here, then M3 is going to be the area of the disk, pi R3 squared, times that surface mass density term, sigma. Okay, just like that. So this is going to be pi onto 0.2 squared times 20. And when I calculated this earlier, the number I got was 2.513, and that's just kilograms. Okay, now we still need to get M2, or sorry, M1. M1 is the square, so we're going to have the sides of the square squared times the surface density term, the surface mass density. So that gets us 0.2 squared times 20. So M1, I calculated that, was just 0.8 kilograms. All right, so now back to our regularly scheduled moment of inertia calculations. So I can 1/2 M3 was 2.513, 0.2 squared plus 2.513 times 0.2 squared, and that gave me 0.1508. Okay. So now let's come in here and let's get I1, which is a square. Okay. And you just look it up. It's geometry, what it is. And it turns out that it's 1/12 the mass of the square, which is M1. And then it's height squared plus width squared. So interestingly, that's really a diagonal. You see Pythagorean's theorem hidden in there. Okay, so it's really the diagonal of the rectangle. Okay, then plus M1 and the offset of that squared. Okay, so plug in our numbers. Our mass here was 0.8. Got 0.2 squared plus 0.2 squared plus 0.8 onto 0.2 squared, and that gave us 0.0373. 0.0373, just like that. Okay, now to get my final answer, then we'll just put it all together. And so I of the oops, was I2, I think as we called that. Yeah. So I3, which is 0.1508 minus the other one, 0.0373. So my whole moment of inertia then becomes 0.1135 kilogram meter squared. Okay. So as you're working these out, now you've got these different tricks. Okay. So you can add things up. If you've got a whole, subtract it from something. Okay. Subtract it from something just like we did here. That'll work out just fine. A couple of things to look out for. Let's say 3 other things to look out for. One is be careful with your geometry in terms of knowing where is your center of mass relative to the axis of rotation. Okay. Number 2, watch out for things like, is this giving me a linear mass density or a surface area density? So watch out for those sorts of things. And then number 3, things to watch out for, I guess it was just 2 after all. Maybe the 3 thing to look out for is the Candyman. Some of you will get that.